I'm Jason Lee. I'm happy to be able to participate in Oktoberfest again this year. Thank you. And this is first of a two-part series on triangulation, starting off with some basics and moving on. This is my full disclosure statement. I have no ties with any of the DNA testing companies, DNA matching companies, so everything I say is based on a love of genetic genealogy. I'm not trying to sell anybody's test kits. As I did the last time I talked about triangulation, I went ahead and conducted a poll in my Facebook group and found that the numbers were pretty much the same. About 80% of the people in the group who are interested in using DNA for finding family had not really put triangulation to use. So there's still a lot of people out there who are interested in the topic but haven't gotten into it yet. I don't really want to put some information out there to help people see what they can do with triangulation if they start to use it. So before I get into how we triangulate, let's talk about why. The most basic answer is that we do triangulation to illuminate DNA connections, and that can help us to identify new relatives, can help us to untangle complicated relationships. So even in cases of endogamy or pedigree collapse or small town genealogy where everybody's related to everybody, triangulation could really help sort things out. I find in a lot of cases it helps me to correct some mistaken assumptions or to correct small errors. So it's a good quality control process. And ultimately, over time, it can help to break down brick walls. One of the more subtle benefits is that by learning about your matches through triangulation, getting some information, finding out what you have in common before you even make contact for the first time, you can lay out that common ground and get really improved response rates. People often complain about how hard it is to get their DNA matches to respond to their messages, and I think that when we find that we have a lot of things in common, when we can point specifically to what we have in common and mention that in our first message, we get a much better response rate, and triangulation certainly helps with that. So moving on to talk about what triangulation is. We talked about why we want to triangulate. Now we talk about what triangulation is. Unfortunately, it's a term that's been used for very different processes in genetic genealogy. It started off as a concept meaning that we look at shared portions of chromosomes and we identify the ancestral source of that chromosome to make progress with our DNA research. It's been expanded to include analysis of DNA match lists. So person A and person B will find that they share DNA, they show up as a match, and what the DNA testing companies provide is a list of people who match both A and B, so shared matches. People look at shared matches, try to find a common thread on that shared match list, and learn from that. And that can be a helpful process. It's a little more messy than DNA segment triangulation, but the important point here is that these two processes are very different. Maurice Gleason has a video where he talks about the two kinds of triangulation. With triangulation of DNA segments, he referred to it as purist triangulation. With triangulation of shared match lists, going through shared match lists to find a common thread, he mentioned the term messy triangulation. In this presentation, I'll simply talk about segment triangulation or DNA segment triangulation and match list triangulation or match list analysis. A point to note here is that this is not math. The term triangulation might bring unpleasant flashbacks to high school geometry. There's no math involved in this except occasional addition. Other than that, we don't get any deeper into math at all. So before I get into segment triangulation, which is what this presentation is really about, I'll talk about an example. I'll discuss an example of match list triangulation, and I'll point out the benefits and challenges. So for me, if I want to employ match list triangulation, I might, for example, look for a descendant of David M. Peoples, who's been a long-standing brick wall. This brick wall is starting to crumble, but I'm still interested, of course, in finding out as much as I can. So I might pull up Jess, who happens to be a descendant of David Peoples. Jess is one of my DNA matches, a real DNA match. And when I pull her up, I find that we share 119 matches. So our shared match list is populated by 119 people who share DNA with both of us. And as I employ the process of match list triangulation and do match list analysis, I'll look through those 119 shared matches and see if I can find some common threads, see if I can find some hints to tell us who David Peoples' parents were, find out some more about the Peoples' relatives. So that's the basic concept. It's very simple, it's very easy. You cast a very wide net, so there's some obvious appeals, some obvious features or obvious benefits that come with this approach. Unfortunately, however, sometimes it can be fairly messy and confusing. So as an example, I'll say that as descendants of David Peoples, Jess and I are also descendants of his one and only wife, Beatty Youngblood. And so our shared match list will also include people who are related to the Youngblood family. And that may not be all bad. If we're interested in learning more about the Youngblood family, that's great. But if we are focused on David Peoples, then we have to contend with the fact that our match list isn't going to be a pure Peoples pool of information. It's going to include Youngblood information as well. And to add to the confusion in this case, not only are Jess and I descendants of David Peoples and Beatty Youngblood, but we are also descendants of an unrelated ancestral couple, Silas Tootle and Nancy Hammock. They're a little bit further back in time, so we expect to find fewer matches relevant to this connection, but we do have to be aware of the fact that we may be focused primarily on David Peoples because he's a brick wall, but we're going to get relatives of Beatty Youngblood, relatives of Silas Tootle, relatives of Nancy Hammock. All of that's going to be mixed together, and it can be difficult to sort things out at times. This issue of multiple shared lines may seem like some other person's problem. Some people seem to think that, well, I don't think that my people were from any tiny village in the middle of nowhere, so this isn't going to affect me. But I'll point out that in America, really the whole world, most people were living in rural locations. In 1790, about 95% of the population was rural. In 1870, it was still 3/4. It wasn't until the 1920s that a 50-50 pattern emerged where about half of the people were in urban locations and half the people were in rural locations. And of course, the 1920s are practically yesterday in terms of genealogy. We really only have to go back a generation or two to get to that time period. So I would say that this is an issue that almost everyone contends with. And where cousin marriage wasn't a factor, we see situations such as family A, siblings marrying siblings from family B, and the descendants have a lot of complicated things to sort out. And I really think triangulation helps us out with that quite a bit. And to hammer this point home, in 1839, Charles Darwin married his first cousin. If anybody would have known the issues that come up with that, it would have been Charles Darwin. And yet he did marry his own first cousin. I don't think that this was particularly rare at any point in history or in any particular location. If you really want to take match list analysis to the higher levels, you can seek out information from Dana Leeds. Dana Leeds has put out a lot of good information about how you can use match list analysis to the best effect. Similarly, I highly recommend the material that E.J. Blom has put out. If you want tools and websites and resources that automate this process and make it as easy as possible. E.J. Blum's really put out a lot of good stuff, and his tools are built in at GEDmatch and MyHeritage DNA. He has his own website, Genetic Affairs, so really recommend this highly. Check it out. You'll learn a lot about match list analysis, and you'll have some tools to have it done for you automatically. So moving on to the main topic here of this presentation, I'll talk about segment triangulation now. The basic idea here is that two people will look at a shared segment of DNA and then move on to look for other people who share that segment of DNA and look for an ancestor or ancestral couple who passed that segment of DNA down through the generations to the present day generation. And basically, in this process, you're mapping out the ancestral source of your DNA on physical locations of chromosomes. So we'll flesh that out here as we move along. Getting back to the basic science here, this is a microscopic image of the genome, all 23 pairs of chromosomes. These are physical entities inside your cells, and we have 23 pairs of chromosomes. And this is what we're looking at when we're analyzing our DNA matches and doing triangulation. We're looking at these physical locations, the real estate of our genome, and we're finding out which ancestor was responsible for the DNA that we have in our cells. And in an upcoming example, I'm going to focus on chromosome 2. We'll flip this image on its side to put it into a configuration that we typically see with chromosome browsers. And this is a chromosome browser for a pair of first cousins. It's a real chromosome browser comparison for two first cousins. And you can see these purple areas. Each one of these bars represents a pair of chromosomes. So each pair of chromosomes is represented by a bar. These purple segments represent sections of chromosomes that are identical. These two first cousins have identical sections of chromosomes as a result of inheriting DNA from their shared grandparents. Those shared grandparents passed DNA down to these two first cousins, and where the two first cousins have DNA that came down from their shared grandparents, they have identical portions of their chromosomes that show up as identical in the chromosome browser. So each of these areas that light up are identical, and each of these areas are what we call DNA segments, identical DNA segments. And because these two people are first cousins, we will expect them to share DNA that they inherited from their shared lines. So in this case, it's Lee, Butler, Smith, and Mullis. These are the lines that they share as a result of their shared grandparents. The shared DNA came from these lines. So again, as I mentioned earlier, we're going to focus a moment on chromosome 2. We're going to make another comparison. We're going to add additional information to this chromosome browser comparison. And we're going to compare these two first cousins with a distant cousin named Randy. And as you can see, they share some segments, some additional segments. They're orange in this case to represent Randy. And in particular, we're going to focus on chromosome 2. So these two first cousins share some DNA with Randy on chromosome 2. And as I mentioned, because of their shared grandparents, we're anticipating ancestry from their shared lines, Lee, Butler, Mims, Smith. And as expected, this distant cousin is related to these first cousins through a shared ancestor, James Thomas Butler. Remember, I mentioned the surname Butler. That is the kind of thing that we expect when we find DNA that triangulates with first cousins. So hopefully this is a pretty good example, pretty clear example. And as this process continues, as you do this over and over, the information can accumulate, the picture becomes more clear. This information propels your research forward. The more you know, the easier it is to learn even more, and it's a really nice process. In preparation for this presentation, I just out of curiosity went to look at my X chromosome. The X chromosome is somewhat easier for men because we only have one copy of the X chromosome that comes from our mother. And so it's a little easier to do the analysis. And I found that almost the entirety of my X chromosome can be mapped out at this point by ancestor. So you can see here, I've got some Langford Spivey segments from my maternal grandfather. I've got some Maddox segments from my maternal grandmother, and some Dean segments from my maternal grandmother. These are the matches whose ancestry helped me to identify the ancestral source of these sections of the chromosome. And here you can see that the left side of the chromosome came from my maternal grandfather Smith. The right side of the chromosome came from my maternal grandmother Mullis, and I narrowed it down even further with these individual segments. Dean is my maternal grandmother's maternal line. Maddox DNA came from my maternal grandmother's father. Langford Spivey came from my maternal grandfather's mom. So as you go along, the nice thing about this is that if I get a new match on my X chromosome, I can immediately begin to narrow things down. I can know where I should expect to find shared ancestry. This process becomes easier and easier over time as the information accumulates. It becomes more powerful. So this is this process where DNA information helps us to understand our genealogy better. It propels our genealogy research, and then our genealogy research in turn helps us to understand our DNA better and propels our DNA research. So this really becomes easier and easier over time. And I'll make this comparison. Basically, triangulation and segment analysis can be awkward and difficult in the beginning. It can seem really challenging, but if you continue to practice over time, it's like riding a bicycle. It's really effortless and easy, and you really don't have to think about it, at least not as much. So some segment triangulation pros and cons, benefits of triangulation. You really focus like a laser on one specific line, one specific shared ancestor, one specific shared ancestral couple. The irrelevant lines and the complicated mess that you can get with matchless triangulation, all of that is a lot easier. A lot of that just melts away. And these benefits are cumulative over time, as I mentioned. As you learn more, you become better at it, and as you accumulate information, your research moves faster and faster. Unfortunately, this information is not available at this information is not available at Ancestry DNA. If you want to do segment triangulation with matches to Ancestry DNA, you have to get each one of those matches to download their DNA file from Ancestry and take it somewhere else so you can make a comparison. Another challenge of segment triangulation is that it does require new knowledge. It does help to have some experience. So you can't just do it on day one as you can with match list analysis. People will debate which is better. Is match list triangulation better? Is segment triangulation better? They both have a role if you're really serious about using your DNA and getting as much out of it as possible. So I would say let's use both. It's not an either-or situation. So moving on to a very specific example of match list triangulation, of DNA segment triangulation, I want to get into some details of the process of segment triangulation in a specific case. And in this case, Of course, as you put together the family trees, you're learning about these families, about these matches, and certainly a lot of very interesting stories with this segment, and we'll get into some of the details as we go along. One of the big challenges in this case was that a lot of these people never responded to any message that I sent out to them, and not a single one of them had a family tree anywhere, at least in the beginning. So it was a pretty daunting challenge, but I could see that this segment had some promise. For one reason for that is because some of the people who shared this segment with me share a very large section of chromosome 1 with me. So it looked to be something that could be really interesting. And in illustrating this case, I'm going to focus on 23andMe tested matches, because the chromosome browser at 23andMe is very powerful, very versatile, and honestly, the images are pretty, so it's nice to put these screenshots in a presentation, and I can really illustrate things well and make any point that I want to make. So this is the chromosome browser comparison, and each of the people that I'm discussing here are being compared directly to me. So it's Bobby versus me, Sherry versus me, Pam versus me, and Mitchell versus me. And as you can see, they're all in roughly the same location. The matching segment the matching segments that these people share with me are roughly in the same location on the same chromosome, suggesting that we might all have shared ancestry. To confirm that we do in fact all share ancestry and that we all inherited a single segment from a single ancestral source, we'll want to compare the people in this triangulation group with each other, not just with me. And we'll highlight the reasons for that later. So I compared everyone with Bobby, and as you can see, we get a very similar result where everyone is matching Bobby in that same location on chromosome 1. And you can go through this process over and over with each person, comparing all of the people of the group with everyone else. 23andMe makes this a little bit easier. You can go to your match list, your shared match list, and where under this phrase shared DNA you see the word yes, that means that triangulation is occurring. So that is very helpful. Can help to expedite this process. And one of the things I do where the chromosome browser is not as flexible and versatile as the chromosome browser at 23andMe is to compare a group of matches not with each other but with one of my kids, and that's a little shortcut that can be very useful, very powerful. So here in the upper portion of the slide you're seeing all of these people being compared with me. Here in the lower portion of the slide we're seeing all of these same people compared with my son, and you can see there's a very similar pattern indicating that all of these people match each other. So that's a nice shortcut that you can take. I think this strategy deserves a presentation of its own, but I just wanted to plant that seed so that you could think about how this could be helpful to you. So some notes on this triangulation group. The matches of this triangulation group share additional DNA with me and my family. It's not all here on chromosome 1 in this one location, so the connections are more robust than you might think if you thought that this is all that we share with these people. Another point here is that when we do triangulation of those other segments of DNA and other locations of the genome, we get similar results. And this process is helpful. Bottom line is we're confirming that we have a shared ancestor somewhere in our tree, and so we look for the source. To crack this case, I'm going to give a quick overview and then go into some details on each one of these people. Pam is an adoptee. Despite this, we could see very clearly that she had a lot of Spivey connections, so that was a really nice clue. Sherry didn't have a family tree available, but she did list some surnames on her 23andMe. Her daughter listed surnames on her 23andMe profile page, and the name Spivey was one of those surnames. That was another strong clue. Bobby basically had nothing on his 23andMe profile, so didn't have much to go on there at all, and he never responded to any messages, may have never logged in to see those messages. Likewise with Mitchell, he had no tree, no surnames, no responses. Fortunately, his name was unique enough that it wasn't impossible to pull the needle out of the haystack. Bobby was worth pursuing despite the limitations because the DNA segment shared was very large, about 60 centimorgans plus. Getting into some details with Pam, turns out that her DNA connections to my family were the most important, despite the fact that she's an adoptee and didn't have much information to share with us. She did, however, share 131 centimorgans with my family, making it easy to see that there were a lot of Spivey clues laying around. Her biological parents were eventually found, and that did confirm the Spivey connections that were suspected. This was tricky, even after she found her half-sister, but ultimately we found shared Spivey ancestry through their shared Spivey father. So very, very clear, even before we made the final confirmation, that this was a Spivey case. Sherry's information added a lot of confidence to this picture. Again, I mentioned that she had some surnames on her profile page. Searching for various combinations of these surnames eventually clarified things, and I was able to build out her tree and found that we were related through our shared ancestors, Daniel Spivey and Selena Langford. Knowing this really worked wonders in getting a response. I put all of this information together before I contacted her for the first time, and that really helped to get an enthusiastic response. So in the past, what I would do in contacting matches was to use 23andMe's form letter. That's really about all I could do, because in a lot of cases I didn't really know much about my matches, even though they might have been interesting. Understandably, the response rate was dismal with this basic form letter. Didn't really give people a reason to reply, but I had to start somewhere, and in the beginning I really didn't know much of anything about the shared connections. But at this point, being able to use triangulation to learn about what we share, what we have in common, and to put that into our communication really has improved response rate. So again, I built out Sherry's tree, contacted her, and said, "Are you related to Fanny so-and-so?" It's her grandmother. She said, "Yes, how are you related? Do you know her?" I gave a long explanation of how I put the information together, and I got a very enthusiastic response, in stark contrast to the kind of responses I got in the past, or the lack thereof. As I mentioned, Bobby was a particularly challenging part of this puzzle, but eventually his sister appeared on MyHeritage with a really minimal tree, but it was enough to get started. I built her tree out and found a Spivey connection. This one was particularly interesting because the Spivey connection was pretty far back in terms of the number of generations, but no other branch of her tree came even close to my neck of the woods. So I was really confident that the Spivey line was the true source of our shared DNA. So that was gratifying. Mitchell, again, was another challenging piece of this puzzle. He didn't have any information other than his name to help us out. He didn't respond to any messages. I suspect he never logged in to see his messages. but because he has a Hispanic surname, which stands out and helps to be the needle in the haystack that's a little easier to pull out. Basically gives me a magnet to pull him out of the haystack. I put his name in a Google search combined with the surname Spivey. Usually don't get lucky with a Hail Mary pass like this, but on the second page of Google results, I found his grandfather's obituary information. As an interesting note in this case, his grandfather happened to be named after our most recent common ancestor. So a really lucky, interesting situation where I was able to find out who he was just on some minimal information. And ultimately, I built out a tree for all of these descendants of the Spivey line in this case, and really nice to be able to do this after several years of research. And this process becomes easier and easier the bigger the databases get, the more I know about my DNA and the more I know about my family tree and my matches family trees. This kind of process really accelerates over time. So the lessons from this case, this is example one in a series of examples. The other examples will be in the second presentation. With experience, the process becomes easier and easier. You can streamline your methods as you learn more. Another lesson, not all cousins, not all family members will be in any given triangulation group. So there are members of my immediate family who are not in this triangulation group on chromosome 1 with the Spivey relatives. But other members of my immediate family, other close cousins, will show up in other triangulation groups in other locations. So there's another triangulation group for the Spivey line on chromosome 17 that includes some of the immediate family members that were excluded from the triangulation group on chromosome 1. So as you go through this process, segment by segment, through the genome, the picture becomes more and more clear. The randomness of DNA inheritance just means that in a lot of cases, you're going to have to extend this process and continue on to get a really nice, clear picture. Another lesson that we learned from this case is that even where there are adoptions or where people don't know who their father is or where people haven't bothered to put together a family tree, we can still make some really nice discoveries if we work hard and persist. Another lesson is that match lists provide insights. All of this starts with a match list, but we focus in like a laser when we apply the methods of segment triangulation. Built-in triangulation features, such as the ones available at 23andMe and MyHeritage, are really helpful in making this process a lot easier. So I hope that people will take advantage of those resources. People have gone through the trouble to build these tools, and I'd really like to see more people using them. And final lesson, as I mentioned earlier, when you share your findings with your matches before you make that first contact, you learn as much as you can. You may not know everything that you want to know, but if you can learn a few things, find some common ground before you make that first contact, you'll do a lot better in getting good responses. So with that, I'll wrap up this part one of the two-part series on triangulation. You can feel free to contact me at my email, jxleefam@gmail.com, with any questions or comments. Thanks again.